All right, welcome everyone. Welcome to the Illinois Greens virtual GreenBuilt home tour. My name is Katie Kaluzny and I'm the Associate Director at the Illinois Green Alliance. 2020 marks the 8th year that the Illinois Green has been fortunate enough to partner with great organizations and home project teams to highlight some awesome green homes throughout Illinois and Northwest Indiana. Today we are going to focus our discussion around all-electric homes, but first I want to tell you just a little bit about the Illinois Green Alliance to get started. Illinois Green is a membership-driven organization. We are a nonprofit that works to promote green buildings and sustainable communities. We believe that green infrastructure is key to strengthening neighborhoods and improving the quality of life for everyone. To move this vision forward, the organization is committed to advancing the latest technology and design through education programs like this one, advocating for new policies like energy benchmarking, and conducting community engagement initiatives that involve thousands of volunteer hours from our green building professional community. The GreenBuilt Home Tour came about from a wonderful volunteer initiative to highlight green home best practices across the state through an annual tour. As you can see, we're holding the tour a little bit differently this year, but we're also so excited to be able to extend our reach to this program to over 300 people that are joining us today. And a big congrats to my colleague, Ashley Marengo, for pivoting our in-person event to making this new month-long virtual program format. It was a big undertaking and we are so excited to get started today. During each date on the tour, during the GreenBuilt Home Series, we'll focus on one of 4 themes. The first one is today on the 8th is all-electric homes. The next one is on Wednesday the 15th, deep energy retrofits. The third event is the 22nd, July 22nd on Passive House. And 7/29 will be on wellness and high performance homes. Let me just go ahead and get started and share my screen here. There we go. I'd like to thank our partners for the tour. Each web event allows you to hear from a number of green building professionals, but our partners really are helping us get the word out about this program as well. So thank you to the Evanston Building Warehouse, the Chicago Association of Realtors, the Green Home Institute, the Passive House Alliance Chicago, Slipstream, the Citizens Utility Board, Phi Theta Kappa Honor Society of Joliet Junior College, the Home Builders Association of Greater Chicago, and a special thank you for the support from the Illinois Science, Energy, and Innovation Foundation. We'd also like to thank our event sponsors for their generous financial support of the GreenBuilt Home Tour Series as a whole. A huge thank you to the ComEd Energy Efficiency Program, Peoples Gas North Shore Gas Energy Efficiency Program, Brink Building Products, Mitsubishi Electric, and Insight Property Services. I'd now like to turn it over to Mike Schaefer at Mitsubishi Electric to share a few words as a key sponsor of today's program. Thank you, Mike.
Hi, everybody. Thank you, Katie. I will take it over here and I have got it now. Thank you. So thank you everyone, and thank you, Katie, for having us. My name's Mike Schaefer. I am the regional sales manager here for Mitsubishi Electric out of Chicago. What I want to do is just take a couple quick minutes and explain to you what Mitsubishi Electric products actually are. So we are residential cooling and heating zone comfort solutions for all homes and commercial applications. But since this is the GreenBuilt Home Tour, we're speaking specifically about residential homes here. We are all electric air source heat pumps. So that's a key thing, as we actually heat and cool homes without the use of natural gas, without the use of fossil fuels. That's why we fit so well with all the homes you're going to see on today's webinar, as well as the homes for the rest of the tour. We are dedicated as a company to energy efficiency, sustainability, and healthy communities. We have been a GreenBuilt Home Tour sponsor for the last 4 years. I've always enjoyed these hot summer weekends of being on site at all of our homes, and I'm excited for the virtual tour that we're going to have this year as well. When we think of Mitsubishi Electric, the kind of conception out in the public is a ductless high wall mount unit. If you think someone says Mitsubishi Electric, generally you might think of a ductless high wall unit. But as you can see from this slide here, we're not just ductless equipment anymore. Yes, we have ductless units that go on the wall or in the ceiling or on the floor, but we also have ducted units. And hopefully we're going to see some of this equipment today because it's in all these homes that we're going to look at. So hopefully we can see some of these ductless or ducted units or some pictures of them. But we have a lot of different options when it comes to equipment for heating and cooling. For more information on Mitsubishi Electric products, about our company, or to find local contractors as well, please visit MitsubishiComfort.com. You can see the link to our website right here. Here's also my contact information as well. So if you need anything or have any questions, please feel free to reach out. I did want to thank everyone involved in the tour and for everyone for hopping on to this webinar today. Special thanks to all the builders, architects, raters, especially Illinois Green, for all the hard work they put in for this tour this year. I know it's a little bit different and there's been a lot of background work, so I'm really excited to see it come to fruition. I am going to be on for this whole webinar, and I'll be looking at the chat box as well. So if somebody has questions related to Mitsubishi Electric equipment, please enter them in the chat. I'll also stick around for the Q&A afterwards as well. I'm going to pass this back over to you now, Katie.
Great, thanks, Mike.
It'll be coming your way.
For your support and for the many years you've supported the home tour. It's been wonderful. Like Mike said, please shoot questions to him in the Q&A or the chat. We'll make sure to answer those through the session when we have time, but we'll definitely also, he'll be around at the end for our facilitated Q&A. And I know that there's lots of questions about this product all the time. It's a really, really cool item and people ask me about it constantly. So thank you for being on today to answer those for us.
Thank you.
I'd now like to turn it over to Brett Bridgeland with the ComEd Energy Efficiency Program to talk about ComEd's All-Electric Pilot Program. I'm going to move on to the next slide and then pass it over to you. So here you go in just a second. Actually, go ahead and get started and I will figure it out. Go ahead, Brett.
All right, yeah, my name is Brett Bridgeland. I manage the implementation of a new pilot from the ComEd Energy Efficiency Program that was launched just this year here in 2020. Let's see if I can advance the slide. And we're excited to be sponsoring the GreenBuilt home tour again this year, and in particular hosting this event with the 4 participants today. So the new offering this year is specifically for the new construction or major renovation of electric homes specifically. So it's an energy efficiency offering where we're offering a $2,000 per home incentive for including a holistic package of energy efficiency measures that starts with efficient all-electric HVAC equipment and water heating, Energy Star appliances, efficient plumbing fixtures, LED lighting, and then of course, first and foremost, a tight and efficient building envelope. Let's see if I can go to the next slide. We also, ComEd is really interested in how electric homes can pair with renewable generation, and so we've got resources that are up on ComEd's website on solar, and so we encourage builders to consider the whole package and how solar power in particular can offset the electric consumption of the home. It's an opportunity for electric homes. We also have resources for electric vehicles and load management in homes. So check those out. Oops. And I'm excited to say in this first year, right off the bat, we got over a dozen participants in this pilot just as it was being launched. And we have 4 of those participants joining today. They're experts. They're going to show their experience. They're going to tell their experiences so far. We would love it if additional people hear their stories and learn from them and then talk to us about how you can participate in the program and get some of those incentives. So here's my contact information. My website, my email address and phone number are up there. Give me a ring or shoot me an email if you want to find out more information. We're also planning to host a builder roundtable in the fall, and so we'd love to have you sign up to participate in that and learn a little bit more in depth from some of the experiences from our pilot participants. And we've got a website there where you can go and find out some more information. So with that, let's get to the show and hear from the experts.
Great. Thank you so much, Brett. I really appreciate it. Thank you for your support and for ComEd's support. And again, Brett's going to be on throughout the session today. So if you have questions about the ComEd All-Electric Pilot, you can share those with Brett in the chat or the Q&A. And he'll also be back on later in the program to answer questions from all of us and to facilitate our Q&A with the speakers. So Brett, if you could give me back control, I will move on to our next session. There we go. So now it's time to get started. You've heard from all of our partners, our sponsors, and I want to tell you a little bit more about today's program. Today's program features 4 all-electric homes located in Chicago, Evanston, Marengo, and Forest Park, Illinois. We'll hear how each home pursued an all-electric path, benefits for the resident, and lessons learned in the construction process. Everyone has worked so hard to bring you a unique presentation about their home, so please bear with us as we transition between presenters and presentation styles. They're all really exciting and fun, and we are new Zoom webinar experts, so hopefully you'll have fun with us today. We'll also share an event recording and follow-up resources and links tomorrow in case you missed anything from the slides that have been shared so far. So first, we're going to hear from Dick Coe from the Evanston Development Cooperative about the Evanston All-Electric ADU. This all-electric new coach house or accessory dwelling unit is built behind an existing 2-flat that demonstrates how sustainability and social equity can work hand in hand through a public-private partnership. So I'm going to move on to the next slide and transfer it over to you, Dick. So take it away. Thank you.
Thank you, Katie, and thank you, Illinois Green, for inviting us to participate. My name is Dick Coe. I am the president of the Evanston Development Cooperative, EDC, as we call it, so we'll refer to ourselves as EDC going forward. Here as a transition. Great. So before starting co-founding EDC with Robbie Marcus, who's on the call as well, I was the faculty director of House by Northwestern. This was Northwestern University's 2017 entry into the Department of Energy Solar Decathlon. I know some of you might have toured the house while I was here in Evanston in fall or late summer of 2017, and this is the final product that we showed in Denver. And this is really the beginning of my journey into this world of design build of small houses and accessory dwelling units. We came back from that competition winning first place in market potential, first place in communications, third in engineering, and one of my favorites, the Student Choice Award for Super Awesome House. So this is really the genesis of a lot of the technologies that we really found during the 2 to 3 years leading up to the Solar Decathlon and what we took into EDC. As we came back from the competition, this is an Evanston newspaper, the Round Table, talking about affordable housing, just to give you a context of how EDC was born. And also, Illinois became the first Illinois city, or Evanston became the first Illinois city to commit to 100% clean, renewable energy. So we're thinking affordable housing on one hand and thinking about sustainability and green on the other. And how do we put the 2 and 2 together? And that's how EDC was born. We are a design builder with this vision to engage Evanston residents in meaningful intergenerational and collaborative societal progress. Our mission is to construct high performance, sensible housing using a locally trained workforce. And these are our values: sensible housing, job creation, community wealth, racial equity, sustainability, and democratic ownership. So we are a worker-owned, resident investor-owned company. And what we do is we build accessory dwelling units, as Katie and Brett mentioned, ADUs as we call them. They come in different shapes and sizes and flavors. This is a graphic from AARP's publication, ABCs of ADUs. They're detached, attached, interior, lower level, upper level. But today we'll focus mainly on detached, primarily because that's the only legal ADU in Evanston right now. And we'll come back to that. In late 2019, Forbes declared that 2020 is the year of the ADU. That was before COVID-19 and a lot of the recent sort of reckoning between social and racial equity. But ADUs is a big deal. And I won't talk too much about what other cities are doing, but I want to highlight that this is a national phenomenon, especially on the West Coast. And here we will hear from Ralph Hoffman, who is on our architecture design team. And
we love the fact that ADUs increase density. And what this represents, it means that sustainability is actually pushed out from the individual dwelling unit into the surrounding community. And what I mean by this is it can take advantage of, or it takes advantage of, existing infrastructure, municipal infrastructure, existing land development, and proximity to public transportation like buses, trains, and Main Street.
Exactly. So as we think about sustainability, it's not just what we put in our homes, but also how our homes connect with the community. In 2018, Evanston allowed the rental of coach houses or ADUs to non-family members. That really was the beginning of ADUs as a viable housing option for homeowners and property owners. As many of you know, Chicago is on its path to legalize ADUs. The ordinance was just introduced in May, and in Cityscape, the Chicago's ADU ordinance was introduced. See what you could build, so you can learn more about that as well. The architects at Booth Hanson has been providing a lot of the initial work, and these are the different types of coach houses, granny flats, ADUs you can build or soon to be able to build in Chicago. So who wants an ADU? Based on our experience talking to homeowners, it's Gen Xers with elderly parents that they are thinking about moving out of a long-term care facility, baby boomers looking to downsize or bringing adult children home, professionals seeking a new home office, young families transitioning to first-time home ownership, and homeowners seeking supplementary income. So it's flexible. It adds to the single-family house, like in this picture. Around here, we call them coach houses, granny flats. And we are Evanston's ADU one-stop shop. That's primarily and the only type of housing we build in Evanston. And you can say, well, how big is the opportunity in Evanston? We also studied the zoning regulations and the lot sizes in Evanston, and every mark here you see is an available coach house to be built in the alley. And more than half of Evanston's single-family lots can support a coach house that's 600 or 800 square feet or bigger. So it's a lot. So the coach house, the ADU that we want to talk about today is really a partnership between the City of Evanston, EDC, and also the nonprofit Housing Opportunity Development Corporation, HODC, at 1930 Jackson. This unique public-private partnership allows us to build an affordable ADU that will be rented out below market rate at 60% of the area median income. This is a big deal because social equity, affordable housing really can be discussed under the net zero energy opportunity or the high performance opportunity. So this report from the Rocky Mountain Institute is a good place to go to learn more about that opportunity. So while a faculty member, our team, we looked at every building solution out there. We looked up and down looking at, well, how would we build a small home that's super energy efficient and practical? We ended up partnering with Eco Panels based out of North Carolina with these structural insulated panels. You'll see on the far right, they come in different shapes and sizes from corner pieces to window cutouts, wall cutout, window and door cutouts. What we liked about them specifically are a few items. One is the corner pieces are solid polyurethane. So once you build a house, you can go around the house and touch nothing but insulation. So there are no thermal bridging between the interior and exterior. And they can also be assembled on site with just manual labor, essentially. Of course, many of you know the performance attributes of structural insulated panels. These are thermal images taken of a stud framed house on the left, the set on the left, and the set on the right, Eco Panels. You can see that you don't see any thermal bridging or any leakage of heat beyond the windows and glazing. So here is a time-lapse video of a Habitat for Humanity project using Eco Panels. This fast assembly is important. We can get under, just under a roof in just a few hours. You'll see they started at just after 9 a.m. in the morning, and within 2 hours, they framed the entire first floor of the single-family home. And you also see, if you can zoom in, you can see where all the electrical box, the outlets are, and also the cutouts. Here is another video where we have a section of the wall panel in a fire pit. Instead of grilling marshmallows, we're grilling the closed cell polyurethane foam. That allows us to demonstrate that, and to show that polyurethane is Class 1 fire retardant. This is the added fire safety that we are excited about. And I love showing this picture because our partner Eco Panels built structures on St. John. When Hurricane Irma came through in 2017, these were the only structures left standing at this resort property from this Coast Guard aerial shot. So we also see the incredible structural strength of building this way.
So ADUs are smaller than typical single-family homes in every square inch of the house. When we design with structural insulated panels, where it gives us the opportunity to actually design beyond energy code requirements. So combined a small footprint with a really efficient building envelope, there's an all-electric ADU becomes a real practical solution. Plus, there's the advantage of not having to run the net.
Good. We'll transition here. And we're delighted to participate in the ComEd Energy Efficiency Program. The electric homes, new construction, ADUs, new construction, detached ADUs are eligible, and we're excited to be a part of this pilot program. So here, we're in the early phases of design, but here is a model that we've developed. This is a coach house that many of you probably have seen in Evanston or nearby communities. One thing I do want to highlight is the zoning that allows us to build 5 feet from the alleyway, and in Evanston it's 20 feet peak to grade, so that we have to dormer out the second floor in order to have the living unit on the second floor. On the ground floor, as most coach houses, you'll see, in this case, a 2-car garage. On the left, you would enter the mudroom, and to the left would be a bench and a coat closet, the stairs to go upstairs. We're envisioning the water hookups for the washer and dryer on the first floor. On the second floor, in this unit in particular, is a 2-bedroom unit with its full bathroom, kitchen. So it's a fully functional living unit. Just to wrap up, so the green features that go into this house are, like I mentioned, the super insulated structural panels, a mini split system like the ones that Mike mentioned, an air source heat pump, energy recovery ventilation. Solar is pending, we're still discussing that. And also, like as Ralph mentioned, the gentle housing density. How do we think beyond each individual homes, but also collectively as a community, how we can add density? Last, just to take home, our take-home message, ADUs are naturally positioned to be all electric. We don't have to pull a natural gas line in the rear yard. And also ADUs provide ample opportunities for energy efficient new construction, even in a built out city like Evanston. And also to think small, how to build small. A tidbit of information is the average new construction in 1950 was roughly 960 square feet. Today it's closer to 2,800 square feet. So thinking small also allows us to be green. And also thinking creatively and sustainably about urban and suburban land use. So those are our take-home messages. I'll leave my information here, and I'm happy to answer questions at the end of this webinar. Thank you, everyone.
Great, thank you so much, Dick. It was it's so interesting seeing this, and I know this is your very first year participating in the home tour, so welcome. I'm sorry it's not in person, but we're really excited to welcome you to our GreenBuilt home tour family, and really enjoyed hearing about the ADU, which is a really timely topic all around the area. So thanks so much for being here for that. Again, like Dick said, please enter your questions for Dick in the chat. We have 4 presentations to go through today, so we're gonna keep rolling with our next one, but we'll be all around for facilitated Q&A at the end. So keep them in there while you're thinking of them, and then we'll get to those a little bit later. Next, I'd like to, our next all-electric home is brought to us by Brian Raskey of Zoetic Building Consultants. The Edison Park Zoetic Home is an all-electric home inspired by WELL and PHIUS standards, which features an ultra-tight envelope construction and reduction of thermal bridging, high indoor air quality, and rigid insulation. I'm going to turn it over to Brian to take us through his home. So thank you, Brian.
Thank you, Katie, and thank you everyone for joining us. My name is Brian Raskey with Zoetic Building Consultants, where our mission is to educate, consult, and advocate for high-performance homes and buildings. I'm going to take you through this new construction panelized home, which is on an infill city lot in the city of Chicago, northwest side. This project is really a culmination of the last 8 years of consulting for high-performance homes and small commercial projects, and we took a lot of direction and inspiration from Energy Star, Lead for Homes, PHIUS, as well as the WELL building standard, and building biologists also consulted with us on the project. I'd like to thank some of our partners, including 2 Point Perspective, the architects who collaborated with us on the design, as well as Brightleaf Homes, who is the current general contractor as we begin to break ground later this month. So just move it here. First of all, this home is on an infill lot, as I mentioned. It's really poised for some great density. You can see here by the City of Chicago zoning map and all the colors there. That's a metro train line there, as well as some businesses. You can see the walk score is very high at 75, access to grocery stores, coffee shops, schools, restaurants, and activities as well. So this is a great, well-connected home to the community. And we think that's important, you know, for our mission and finding a better way to build these homes and connect them with our lifestyles. And we do that through the different attributes, the Zoetic attributes, including healthy, safe, comfortable, smart, sustainable, and energy efficient resiliency. Moving on. Like I said, this is a culmination of the last 8 years of our experience at Zoetic Building Consultants, where the bulk of our work is mechanical, electrical, and plumbing consulting for architects, homeowners, and developers. But we really want to take a holistic approach. And so over the last 4 years, we considered 10 different high performance methods in order to construct this home. You know, two of which were wood SIPs and 3 of which were steel structural insulated panels. And we actually traveled to 4 manufacturing facilities across North America, and we ended up selecting a steel SIP system for the same reasons that Dick shared, with the low thermal bridging and the ease of installation. So one thing that we'd like to point out at this point is, after doing 400 load calculations for heating and cooling, this kind of popped onto our radar back in 2017, that even with the increasing energy codes and participation with the municipalities, 4 in 10 custom home builds are still not properly sizing or designing their HVAC systems to meet the needs of the home. So this is something that the EPA published and was summarized here in this bulletin. So diving into some technical aspects of the home, once we solidified which panel system we were using, we got to work, our bread and butter of doing the calculations to find out what's going to take to heat and cool the home here in the Chicago environment. What we thought was interesting was that the heating load's actually too low for a well-controlled furnace. And we define a well-controlled furnace to be more than 1 stage of heat, more than on and off. And that's because it's not always 0 degrees out, not always a polar vortex here in Chicago. Even though we do have a very cold climate, there's plenty of hours in the year where that furnace should be doing comfort, but not on full blast. And so when we look at the market, this kind of pointed us in the direction of, hey, maybe we should consider heat pumps. A cold climate heat pump might make sense with these low loads of 32,000, 33,000 BTUs of heat here at -10 degrees here in Chicago. So just a little background here. A heat pump is really just an air conditioner running in reverse, right? So we're all familiar with how an air conditioner works. And this is just, the image here is showing how an air conditioner would typically work, right? You're trying to push cool air into the home and hot air out through a compression cycle or refrigerant cycle. And just running this in reverse with the technologies that have become available in the last decade, we really thought this was an opportunity to show what this technology can do, and that the efficiencies are really there to be had and participate in some of these efficiency programs like the one that ComEd has come out with, the all-electric home. And it just so happens that the timing has been great for that with this home. And that unlike a furnace, a heat pump doesn't create the energy through the use of a fossil fuel or electric resistance coil. It's actually transferring heat. So because it's not creating that heat and transferring it, it's doing a lot less work, and you can get efficiencies of 250 to 350%, while a furnace tops out at 97, 98% efficient. So we really like the synergistic nature of that. So here's some of those heat pumps that Mike showed early on. We are using Mitsubishi cold climate heat pump on the right, top right there. And again, With the American market, we realize that not everybody wants to see their HVAC equipment in each home, each room that they walk into. And so we've chosen to duct those units into 3 separate zones, which gives great controllability for the eventual homeowner, but also it doesn't need to heat or overcool the space when the sun isn't shining into those particular exposures of the home as well. On the ventilation side, this is a diagram of the energy recovery ventilator. And this is going to be a great system for us in terms of making sure our well-sealed home is also well ventilated. Fresh outside air is going to come in through the building and into this appliance and pass through this heat exchanger, and we'll be exhausting air from the home and recovering heat and humidity from it, and then rejecting it to the outside. So this is going to be a completely separate system. We're proponents of doing more than the code minimum, and so the code minimum is just a hole in the wall that might go to your furnace or to your air handling system. But also we wanted to look at what other technologies were out there, and so a good ERV or HRV will do that heat exchange through the plate and frame heat exchanger, or maybe you can do an energy wheel. But we were actually found a local manufacturer who uses the heat pump technology and a dedicated ventilation system. And so we always talk about the HVAC system, or the heating, ventilating, and air conditioning system. And we've chosen to separate the ventilation from the heating and air conditioning system. And we feel like that's a great decision for our project and the goals that it has. Because if you've got an appliance who's trying to do more than one task, it might not do those tasks well. It may accomplish the task, but it's not set or designed to do that well. So we wanted to do that. And so here's just a snapshot of the second floor of the HVAC plan. And it's color coded with purple ductwork being the supply ductwork. So that's the ductwork that's going to take your heating and cooling air and deliver it to the spaces on a room by room basis. And then you've got the outside air from the ERV, which is going to deliver fresh air to those occupants. So we're delivering fresh air directly to those bedrooms so that each occupant can get a great night's sleep and have a high volume of oxygen available to them. The green ducts are the return ducts to the zoned equipment, and we have a dedicated exhaust system there in that mustardy yellow color. So a little bit more ductwork and design that went into the home, but we feel like Zoetic homes are engineered homes and that they should be designed to perform the tasks to meet the goals of the project. So going down the path of electrification, once we decided to do that with the high efficiency panels, we needed to pick a hot water heater, and we needed to decide whether that electric hot water heater was going to have a tank or if it was going to be tankless. And so there's pros and cons there, but we wanted to limit the demand load on the electrical infrastructure and also on the plumbing infrastructure, and make sure there wasn't too much demand load or pressure drop in either of those systems. There was a bunch of discussions about having 50 gallons of hot water sitting around, but we looked at it from a resiliency point of view and saying, you know what, if there were a power outage, that maybe having 50 gallons of hot water sitting around for use might be a benefit and not necessarily an energy penalty. Part of the Zoetic mentality is to look at things holistically, and if you're always looking at energy efficiency as a kind of a myopic approach as your sole goal, you might miss other opportunities. If you really wanted to be the most energy efficient, we could just set our thermostats back 10 degrees and then put on an extra layer during the winter, but that's not the reality of how we live in our homes these days. Another benefit of that heat pump water tank is that it can cool and dehumidify the home while you're getting that benefit of hot water. So that we thought that was with our humid and hot summers, we thought that was a benefit in our climate. So that's the way we went with the heat pump water tank. In addition to that, we've got some hot water recovery, and this is just a copper drain that serves the showers. And so 2 showers from the second floor will flow through this copper coil and recover that hot water heat. If you think about taking a shower, the hot water just goes straight down the drain, and there's an opportunity to recover that and put it back into that water tank. So this might take our energy efficiency up to 400% on that hot water heat pump hot water tank. So again, to complete the electrification of the home, we still had to think about what we're going to do with the clothes dryer and the cooking in the kitchen there. So we found a great product from Whirlpool. It's a 7.4 cubic foot ventless clothes dryer. This is great for maintaining air tightness in the home. It's not another 4-inch hole in the wall. And so that actually, again, our third appliance now using heat pump technology in the home. And then an induction cooktop to finish it out. So that's what's allowed us to not bring any gas to the home. So that's something was important to us. Being an infill lot with no natural gas on site, we decided, why spend the time, energy, and money to create that infrastructure and pay for that infrastructure if we don't have to. And then, of course, getting the largest solar array we could to offset that. That's a 25-panel solar array facing southwest. So great production out of that 8.1 kilowatt array. So at this point, I'd like to transition from the electrification of the home to the wellness aspects of the home. You know, what is a zoetic home? And so to begin with, zoetic is a dictionary word. It means of or relating to life, living, vital. And so that's kind of the definition of a home in our perspective. Why put a roof over your head if it's going to make you sick or make you uncomfortable? So we want to really look again at holistically what a home is intended to do, and we'll look at that through our lens of healthy, safe, comfortable, smart, sustainable energy efficiency and resiliency. So just starting here with healthy and safe, you know, the home with the metal framing and EMF shielding installed along the exterior walls maintains low electromagnetic fields. And so this protects the occupants from your neighbor's Wi-Fi, the ComEd smart meters, which are emitting a high frequency signal, and nearby LTE and 5G cell towers. This is something that the building biologist brought to us. Also, the home's going to be filled with low VOC trim cabinetry and millwork. It's going to be intending for formaldehyde-free construction materials, water-based paints and finishes. Whatever does happen to have VOCs should be picked up by the ERV system and VOC sequestering drywall. That ERV system will be monitored by an indoor air quality monitoring system, and the exhaust fan system is a dedicated system as well. And both of these systems will make informed decisions based on how the home should adapt, you know, depending on changing conditions inside of the home and out. So if it's a very hot, high humidity day, the ERV will know this and say, you know what, maybe I'm going to bring in a little bit less air, as long as I'm monitoring CO2 and VOCs. Again, synergistic and holistic thinking on these things. So along those lines, the ventilation system is designed to be future-proof. You know, with the atmospheric CO2 that continues to rise, we made sure that this ERV system has the ability to over-ventilate by today's standards, but maybe in a decade or two, that will not be over-ventilation. That'll be the right amount of ventilation. And that's controlled by variable speed fans. So you're not over-ventilating now, you're ventilating the right amount. Also, the ventilation systems will be outfitted with ultra-effective filtration media and active pathogen eradication technologies. So bipolar ionization as well as UV technologies can be used to make the home a healthier, safer place to live in, especially given that we spend 90% of our time indoors. I read something recently about the EPA producing some research about cancer being more likely for people who spend their day in the home. So working from home now is going to be more of a concern, and depending on the air quality in our home. So that's something that we wanted to focus on. You know, the multi-zoning heating and air conditioning system is equipped to allow for self-quarantine and multiple occupants in the home, and that's based on those zoning, right? So that you can sequester yourself and not be spreading air throughout the house unless that is your intent. And then also, healthy and safe, the SIP panel system has great wind, fire, water, pest, and seismic resistance. So this is going to be a safe home structurally as well. On the comfortable and smart sides of the Zoetic attributes, you know, we've zoned this home and we right-sized the heating and air conditioning system to deliver comfort to each space at the right time. And so that, coupled with the thermal mass in the wall assembly and the concrete floors, this is going to deliver, we believe this home is going to deliver comfort that a lot of us haven't experienced before. The triple pane windows not only provide efficiency and comfort near the outside walls, but also reduce sound from the nearby metro station and streets. Also, being that it's an all-electric home, we've got an electrical signal clarifier to make the grid, to clean up the local grid and make this all-electric appliances, home, and solar panels even more efficient. So just want to thank everyone, including Brightleaf and our Architects 2-Point Perspective, for collaborating on the design and participating in the project. I'll be here for the rest of the remainder of the webinar.
Great, thank you so much, Brian. Please be sure to ask your questions in the chat for Brian. I saw a lot of awesome questions coming in during that presentation and the presentation before, and I see Mike Schaefer killing it, answering questions in the chat. So thank you, Mike, for following through on those as we go along. But if we haven't gotten to your question, again, we'll get to it at the end. But right now we're gonna go live with Scott Sanders from Brightleaf Homes. Scott will be sharing a tour of the Burkhart Court Townhomes in Forest Park, Illinois. This project features a row of 3 townhomes built with different HVAC systems and many awesome green home features. Scott, you are officially on Spotlight, so show us around.
Awesome. Katie, can you see me standing live in the street? Is that okay?
I sure can. Great.
Fantastic. Good. Katie stole some of my thunder. I am Scott from Brightleaf, as she said. We are a high-performance builder, remodeler, and real estate company specializing in third-party certified high-performance homes in the whole Chicago area. This is our home that we built and developed on this tour, and we're also actually partnering with 2 other builders and developers on the tour this year for 2 more homes. One of those is the one you just saw with Brian. This particular project, Flipside Forest Park, as Katie mentioned, is actually a 3-unit infill project in suburban Forest Park right near I-290 in Harlem. We're about a half a block north of the Madison corridor with lots of shopping and restaurants and all kinds of things. And originally on this property, there was a dilapidated 2-flat that stood here that had been abandoned and foreclosed for quite a while before we were able to pick it up and develop it. So I mentioned that this is a high density project, and I went to a live video here so you could see sort of the configuration. This is a little bit innovative for what Forest Park allowed in the zoning regulations. We have what are essentially 3 single-family homes that are on this lot, but they're facing sideways, hence the name Flipside for us, with the benefits of a townhouse living situation and taxing, but the benefits also of a single-family detached home because the garages actually separate the living space between each one of the single-family homes. So driveway and alley runs along the side here, and then there are 3 garages that serve each one of these 3 units. I'm going to transition inside now and jump into an actual slideshow presentation because I can't show you all of the cool things that are going on in all of these homes because they're sold, but I do want to jump through a bunch of pictures and give you a little bit of narration going through. So Katie or Ashley, if you could switch the video to the presentation while I walk in and get in front of the computer, that would be great. And so I'm back on audio here. Katie, I hope I'm up with the presentation on the inside. Looks like I might not quite be just yet, so I'll talk a little bit about what Katie and Ashley are working to pull up. The background of this project is it is a DOE Zero Energy Ready certified project that also carries the EPA Energy Star and WaterSense labels. It would qualify for LEED Gold status if we were to certify to the program, but we chose not to do that on this particular project just for cost reasons. Sorry, working to get control from Katie. And then this other aspect of this project is that Brightleaf is able to use this 3-unit townhouse project as a research and development test bed to try out all kinds of different building materials, mechanical systems, installation strategies, and lots of other things along the way. The reason that we were able to do this was because we had 3 of the same building envelope with same window assemblies, same floor plan layouts, and things like that going forward. Thank you to whoever the ghost is helping me move through my slide presentation. There we go. Awesome. Right on now. So the first home that you see on the screen here actually has, is our conventional natural gas sort of base home unit. It has natural gas heating, natural gas cooling, natural gas range, and also the heating system here is sort of a conventional system in a 60,000 BTU forced air furnace. There we go. That's the picture I want to show so we can see the natural gas range. All of the homes here at this project, I am sorry, we're having some weird technical difficulties going on here.
Sorry about that, Scott. I think just move the slides from your cursor and not the arrows.
Got it. Fantastic. So each of the homes here, flip side, has 4 bedrooms, 3.5 bathrooms, full finished basements, half in, half out of the ground. We want to let a lot of natural light pour in those windows downstairs in the basement as well. We want to try and keep the living space as great as possible considering the relatively small footprint that we have here in these homes. So I mentioned actually that the first home was sort of the control unit with the natural gas furnace. And you can see that actually on the left. It's a 96% efficient 2-stage furnace that goes through the regular conventional ductwork system like Mike was talking about. On the right-hand side is actually the system for the rest of the homes, which is an air source mini-split heat pump that's ducted throughout the rest of the project. Both the middle unit and the end unit have that same air source heat pump ducted through the conventional ductwork system. The next slide that we've got here going on is the actual back of the unit. So here, this is the outdoor unit that Mike was talking about for the air source heat pump. And what you can see is the solar disconnect here. These homes all have solar panels on them. They all have a 10-panel, about 3.1 kilowatt system. But because of how tight this site is, I can't really get a great picture to show you the solar panels. So you're going to have to either believe me or look at the solar disconnect here to prove that I'm not lying to you. Or in the other case, you could actually check on the production usage inside. And so that's what we've got here. We've got actually a rainforest automation energy monitoring unit where this picture was taken in the early afternoon inside one of the homes. This meter is actually linked to our smart meter on the outside of the home, and it's validating the actual production of the panel system, showing the net power being pushed back to the grid. One cool thing of note here is that this is the middle of the day in mid-June, and we're only pushing 2.5 kilowatts of power back to the grid when we have a 3.1 kilowatt system. So it seems like we've got some production missing. What gives? Well, the home is still using baseload power for things like HVAC in the middle of the day, or clocks, or our active radon mitigation system, and anything else plugged in at, I don't know, 2 o'clock on a Tuesday. So there's some power loss among the things that are in the home actually operating, that phantom or baseload. And then we do have some loss over the solar panel wiring and power inverter, making up for that other 0.6 of a kilowatt or so. So speaking of inverters, I think you remember that one of the things I said right at the beginning of the presentation while we were having all of our technical difficulties was this was an R&D test bed for what Brightleaf is trying to do. And as part of that, we actually tried out 3 different inverter technologies for solar panels. We put solar as standard on all of the Brightleaf homes that we build speculatively, and we option it to all of our custom home clients. And while we don't have time to go into the details of central inverters versus microinverters, one thing I wanted to mention is that we're looking more into the adaptability for future integration of battery cells and connection to EVs for additional storage or emergency use. Not all clients can afford that right now. It's not necessarily cost effective right now, and it might not be necessary right now due to the reliability of the grid. But just like our homes of the future for other reasons, we want to make sure that the solar systems are also set up to be homes of the future as well. So we installed 3 different inverters at Flipside Forest Park, a standard central inverter, a microinverter system, and then an innovative central inverter system created by a company named Pika, who developed an advanced inverter that could be expanded with storage and some additional features in the future. That's the blue box that you see here on the screen. Since the beginning of the year when we installed the blue Pika system, their islanding inverter is what it was called here. Pika was actually bought out by Generac, who is coincidentally the company most known for propane and natural gas generators, and they rebranded it to PowerCell. So it's funny how technology changes and how companies change their product line, with Generac getting more into the solar and solar inverter business as well. So as long as we have that picture up, actually, I'm going to take a snapshot forward and highlight here. This inverter was actually installed in the garage. So we have the ability to test if the inverters are affected by extreme temperatures, either heat or cold, in the summer or the winter. And this also shows our EV plug out in the garage as well, to make sure, again, that our systems are basically future-proof for someone to add an EV in the future. We want to try and stay ahead of that curve and make sure that our homeowners have the ability to do that. So in addition to the systems that we have on the technology side or the solar side or the green side, we also want to make sure that the system is, our homes are technologically advanced and ready for the future. So we made it a point to try out some of the other types of future possibilities for connectivity, for energy control, automation, and those kinds of things. One of those was Leviton's Smart Load Center, which is on the right here. That's actually the circuit breaker panel for this house. It looks a lot better than a regular gray circuit box, which is cool, but it also has whole home energy monitoring capability and individual circuit monitoring and control if desired. So we also have 100% LED lighting as a Brightleaf standard, a number of the lighting controllers to make sure that indoor and outdoor lighting can be controlled properly and not left on all the time, and then also a whole home wireless mesh system for Wi-Fi that not only helps our solar inverter stay connected to what we're trying to do in terms of our Wi-Fi, but also allows a lot of other connectivity around the home overall. Utility bills for this home, you can see, are pretty darn low. This is a preliminary bill that we have here, showing about $63 a month. What we have after that is some of the other features about this house go beyond energy efficiency. One of the homes was actually stick framed conventionally, which is that white Tyvek home wrap in the front. And then interestingly, the middle unit, which you see in the green zip wall system out there, a different type of exterior weather barrier, was actually panelized in a factory by Walnut Custom Components out in central Illinois. So they actually built those open wall panels in a controlled environment, you can see here with actually the computer screens there, and then loaded them onto a truck and into bunks to be able to transport them out to site and be erected in a panelized fashion with the framer basically just tilting them up. So we can make awesomely efficient homes, but they've got to look great too. And we hope the interiors of these homes look as good as they function in terms of energy. So with that, I will wrap up this presentation, answer any questions along with the end, along with everyone else. And if you've got any questions, please don't hesitate to reach out to us at the website or through Instagram, YouTube, or anything like that. Thanks very much.
Awesome. Thank you so much, Scott, for the awesome presentation and for testing our webinar wizardry skills today. Please share your questions for Scott in the Q&A, as he mentioned, and we'll get back to that shortly. But now, last but not least, we're going to hear from Brandon Weiss about the Wildwood Passive Power Model located in Marengo, Illinois. This is a model home in a new development, Wildwood, that converges passive house technologies and solar energy storage in order to avoid a negative duck curve effect and require no peak power plant energy for most of the year. Brandon has put together a video for us, so it's like he's on site, but he'll be back in Q&A live during our Q&A in just a few minutes. So thanks, Brandon, for putting this together. And Ashley, you can press play.
Imagine a community full of homes that create an environment conducive to life with natural, toxin-free materials that generated all of its own power from the sun, that is able to store over 0.5 megawatt of energy, full of homes third-party certified to the highest level of energy, resiliency, and building science certifications available, with homes that are designed to connect you to the natural world, that is restoring native habitats to pre-settlement conditions, and with ample experiential amenities to help promote an outdoor, healthy lifestyle. This is Wildwood, a community unlike any other.
Hi, welcome to Wildwood and Marengo. This is the Showcase Model Home in a development that currently has 27 other lots for sale pre-construction. Some of the unique elements of this house are that it is Passive House certified, so that is a conservation first certification process, ensuring that we have the lowest possible loads due to great insulation and great craftsmanship to bring a great building together. To couple that, we have net zero solar installation on this house, and then added onto that is a battery backup system for true resiliency, as well as to be able to use energy when you want to and kind of deal with the time of use rates and get your great benefit from that. This home is also all electric, so that true net zero is actually true net zero. We don't have any natural gas or any other energy sources that we're using this home, so We'll see some of those features and what appliances make that up when we go inside. The home is also using off-site construction technologies, which is the future of construction in my opinion. So built off-site, this whole house was under roof in less than 2 weeks, protected, windows in, weather barriers on, and ready to continue construction, which is really great and pretty profound for a building of this level of complication with the building envelope and the redundancy in some of the elements we have here. And then most excitingly is the health and wellness of this home. So this house is built using toxin-free materials. It's built using natural products and showcasing those natural products on the inside to help also tie the occupant to the outdoor environment around us, which is super beautiful in this area, and really using biophilic design principles. Let's check out the inside. So welcome to the flex room. We've designed this room and built it so that it can be enclosed for some privacy and be used for a multitude of different uses. It could be an office space, kids' playroom, among many others. I'll show you one of my favorite uses. When we open this door, we connect this space to the dining room. So for those holiday parties, Thanksgiving, you can really either extend your table through and have many more people, or you could have children in one room and the adults in another room.
Imagine having an organic meal at this table with fresh ingredients from the vegetable garden right outside these windows, and with grass-fed meat that was delivered to the community by partnering local farmers with as much dedication to their craft as we pay to ours. The serving peninsula between the kitchen and dining is accessible from both sides to store cookware, serving platters, and dishes for different occasions. The countertop was designed to allow food setup for those large gatherings and holiday celebrations. Any farm-to-table or hobbyist chef will really appreciate the large open kitchen with Fisher & Paykel appliance package. The appliance package includes an upper steam oven and a double oven setup, which is the healthiest and most energy-efficient way to cook. Love it when health and efficiency converge. The cooktop uses induction technology to give the chef complete control of temperature that is the same every time you cook at a certain setting, allowable by the digital controls. This is also the fastest way of cooking and the safest type of cooking appliance. Even top Michelin chefs are moving to induction. The hood above the cooktop has both grease and charcoal filtration. Any residual odors will get evacuated by the ERV exhaust ports, which are near the ceiling in the light cove. The island in this home includes a farmhouse-style sink and dual-drawer dishwasher. That makes entertaining much easier and helps to phase cleanup from large gatherings or keep the party going. You can run one load while the other's getting loaded. It also offers sanitize mode, which is reassuring for cleanliness.
That kitchen just walks you right out to the beautiful natural environment. You see the wetlands, the prairie restoration going on this lot, as well as throughout this entire development, restoring native habitats back to what they should be. I've seen animals and insects and even reptilious creatures out here that I have not ever seen in Illinois, so it's a pretty spectacular place to get connected with nature. And a great place to dine al fresco outside. A lot of wildwood is being preserved for natural habitats, so we have a lot of woodlands that are being preserved. That is not even a lot there, that's just deep woods that you're able to hike through and experience true nature here. You see we're standing in the turf zone here, which is one of the few areas of turf which is mowed by an electric mower. Who wants to hear their neighbor mowing with gas mowers anymore? You'll never hear that in wildwood because the maintenance of the landscape is taken care of for you and is done all electric, so you don't hear those roaring engines. And then up on the roof, this is what gives us the net zero capability, is the solar PV array. That's a 6 kilowatt array. You also see a lot of the farmhouse design aesthetic here from the outside. Use a lot of simple materials, but have paid attention to detailing. So you'll see some extra trim around windows, just to make it a little punchier. Let the thickness of the walls speak and allow you to really appreciate, how thick and efficient this house really is. This house has 2x6 walls full of cavity insulation. That's R23, and that's followed by an air barrier on your rigid sheathing, which is followed by 6 inches of continuous exterior insulation on the walls, and then a ventilated rain screen with siding. Here in your family room, you can cozy up to an electric fireplace that puts a realistic flame. And again, when you're looking there, looking out the nature, looking out the wetlands, it really, again, connects you to the outdoor environment. And, fire is one of those human elements that we've been connected to for so long. Now you're looking at the exposed ceilings that are wood. We didn't want to cover this house or clad the whole interior with drywall. The lungs of the home, which is our energy recovery ventilator. So that's what exhausts the stale air out of the home, any moisture and odors, through the kitchen, laundry, bathroom area, and then brings that fresh filtered air throughout the entire home, servicing all the bedrooms and living spaces in the home. Here you can see the stairs. We kept the open riser, and the stairs for the basement and from the first floor to the second floor are stacked, which allows for nice lighting to flow through the house. The second floor also has a fully ducted mini split unit that services all the bedrooms and the bathroom. You'll see the triple glazed European windows, which maximize our energy performance. They allow the light we want to come give us free heat in the winter to come through in the wintertime. But also with 3 panes of glass, and the spacing of European windows allows for more insulated gas between the glass. The beautiful thing about a passive house is that the comfort that comes from it is something that not as expected. A lot of people build it for the efficiency. When you come in, you wouldn't hear noises like that car or motorcycle that just drove by. A prefabricated shower base with a linear drain to give it the modern design we're looking for. All the tile has an epoxy-based grout for ultimate durability. Never needs to be sealed. Is stain, mildew resistant. So we may not have noticed this before, but this is the laundry room here. Centrally located amongst the 4 bedrooms behind this barn door to just bring full circle our farmhouse design. It is a stackable unit, but it has large capacity. The dryer is a heat pump dryer, so all electric, just like everything else in the house. And also has dry sense technology to know the clothes are actually dry at the end of the cycle. This bedroom has dual walk-in closets. You'll also notice high up on that bed wall, there's 2 ports. One is your ventilation port, bringing in that fresh, continuous outdoor filtered air into the house to make sure the CO2 levels don't get too high during your sleep to maximize your sleep and the regenerative nature of your sleep. And then we have the other port that is a heating and cooling port that's ducted from that ducted mini split heat pump. In this bathroom, when you wake up in the morning, you can have nice, toasty, warm feet come in here because we have underfloor electric heating built into the tile system here. It also works as a nice backup heat source for wintertime. All the appliances in the bathrooms are water sense rated for ultimate water efficiency. Just like we go the home energy efficient, we want to go water efficient as well and really conserve all of our natural resources. Now in passive house, who doesn't want to see the mechanical system? So let's head down to the basement and check out those. Down low there you see the thermal break between the slab and the Stego barrier tape. So the Stego barrier tape is the air barrier that goes underneath, prevents any soil gases from coming up as well. And the insulation divides the wall from the slab. The slab also has R20 insulation below it. And we have continuous exterior insulation around the entire exterior of the foundation wall so that we can keep the inside exposed. Now we're looking at the powerhouse of the home. This is the electric distribution system, as well as the battery backup storage and the inverter for the solar. First, here's the battery. And the battery system is the Sonnen EcoLinks. And this allows us to back up the critical loads panel here. So this sub-panel we're using as the critical loads panel and contain all the critical components of the home that we would want to operate in the event of a grid outage. So we have things like the heating and cooling system, the steam oven, so you can cook in an outage. We have safety lighting, so lighting throughout the home to be able to navigate and get to where you want to go safely. We have the refrigerator, so you don't lose your food and continue to store your food. We have the sump pump and the ejector pump, continue to operate the home so you don't have any water backing into the basement, which would not be a healthy environment. Your well pump stays active, so you get your fresh filtered water consistently throughout an outage situation. And maybe most importantly, I think it's important, is the lungs of the home, that ERV, keep that operating so you're continuing to move fresh filtered air throughout the home in your airtight building. All you see the antennas here coming underneath these panels. All the circuits are being monitored by a circuit monitor. That allows us to understand, and for occupants to understand where the energy is going, and that allows them to improve their behavior. They can't improve what they don't know.
So you just saw Brandon Weiss give a tour of this house. What you didn't see is the trick he pulled on me. So we've been friends for a long time, and I started investigating the house after the video. And what does he do? He throws the main breaker. Should that worry me? I guess not. So there's renewables on that house. We all saw it. So it was less than a blink of a switch. It was like that. That battery came on and the lights were back on. Was I impressed? Yeah, I was. Am I impressed? Yeah. And here it is again, always surprising me.
Mark, thanks for coming out. Thanks for the candy out here and the little plug. Always appreciate you having me on site.
Well, when I took the train in from Chicago, it was like a jiff, right? I was here, you picked me up, we had our smoothies, and we were off, and then I got to see all the prairie life here, and I could have brought a sandwich and stayed in the park, but I wanted to get back in the home for your video. So
yeah, 15 minutes from the train station. Like, Marengo is not what you thought coming from the city. It's not.
I got to like 3 texts, and that was it.
Yeah, we can get to 90 and 4-minute drive off of the new 23 entrance and exit ramps there, and it's a beautiful thing. Well, I know you got to get going.
I do, yeah.
You go to O'Hare, 40-minute drive to O'Hare. I know you don't fly, so that's probably not the
Say I don't fly. He knows me that well, folks.
So where you going, Mark?
You know, I'm going up to Lake Geneva. How far is that from here?
23, 25 minutes, something like that.
Who wants to meet me in Lake Geneva? It's 23 minutes. If I'm there first, you're buying the next round.
Just shows you how connected we are here. Mark, pleasure to have you out here.
Thank you so much, Brandon. This is an awesome video and tour, and I loved a good Mark Willie cameo. And also that the end part really felt like our normal in-person home tours where people are chatting at the end and able to ask a lot of questions and interact with each other. So thank you for sharing that. Thank you for being on the tour again this year. If anyone was having trouble with their internet speeds or the video footage in full, Brandon also has a YouTube link for this video, so we'll share it afterwards so that you guys can take a look as well. I'm going to pull up some more PowerPoints really quick before we get to Q&A. I want to introduce one of our awesome volunteers, Albert Pope. Albert is a volunteer in our Climate Action Ambassador Program, and he is going to be here today to tell us a little bit more about what you can do in your own home to go all electric. What can you start doing? What are some tips? And so our Climate Action Ambassador Program is really fun. It's new this year. We trained everyone up earlier this spring, and then everyone had to go home and not interact with anyone. So we're really excited that our Climate Action Ambassadors can join us virtually and share a few tips here with us remotely. So Albert, I'm going to give you controls, and then the arrows are down in the corner.
Great, thank you, Katie. Will that PowerPoint pop up for me? Or shall I share mine?
Are you seeing it now?
I don't know how everybody else sees it. All I see is Climate Action Ambassador.
Yep, and then let's go to the next slide. There you go.
Thank you. Great. So yeah, my name is Albert Pope. I'm a Climate Action Ambassador, a volunteer with Illinois Green Alliance. Here to talk to you about a couple options, appliance options for an all-electric home. The first one will be about stoves. The second one is about water heaters. So the first option we have is an induction stove. Induction stoves are really an upgrade because they're quite a bit more expensive than a traditional electric stove. They can cost between $1,000 and $3,000, but they're more powerful and accurate. My professional chef friend recommended that I get one for my home. They're more efficient. They're 84% efficient versus 73% efficient, according to the Department of Energy. It's really quite nice once you get used to them. You have to get over that you're not going to be able to see what's happening with a gas stove where you know exactly how many BTUs you're putting into that vessel or that pot or pan. So you do need to get used to it a little bit, but you'll boil water about 40% faster than a traditional stove. and versus a natural gas stove, which is only about 40% efficient because you lose about 60 or 50% of the heat just to the air. It's quite a faster and more accurate way of cooking. It's also safer. You don't have nitrous oxide from gas going into your house. And compared to a traditional electric stove, you don't have a problem of heating up a coil or the surface of the stove. It's actually heating up the vessel itself. So what it's doing is through magnetic induction, an AC current is running in there, and it's exciting all of the electrons in the pot itself, which brings us to which pots work. The pots that work are the pots that you can stick a magnet on and they'll stick. If it's pure aluminum, it's not going to work. So you need something with ferrous metal in it. So yes, an iron skillet will work great. And next we'll move on to water heaters. Let's see if that slide pops up here. Thank you. Now there are three different options I want to talk to you about with water heaters. And I organized them by cost. The first is a tankless hot water heater, also known as an instantaneous or on-demand hot water. The second is a heat pump, which you heard about being installed in several of these homes, actually, quite an efficient option. And the third is a solar hot water heating, the most expensive, but once you install it, arguably free. So let's talk about the first one, tankless hot water heaters. Tankless hot water heaters are great because you can stick them on the wall. They don't take up much room. And if you have a campus-like setting or perhaps outbuildings on your estate, you can put them right at the point of use, and you can save energy that way as well, as opposed to one centralized storage tank. So if you've got a spread out campus, that's really great. They also are more efficient than a traditional storage hot water heater. But it's not something that's going to pay for itself as an energy conservation measure would. It's not that financially compelling. Which brings us to option number two, which is the heat pump. That's between $1,200 and $3,500 installed. And these are great because for each watt of energy that you put into the system, you get out 3 watts of hot water, which is where this idea of 300% efficiency comes in versus a 100% resistance coil efficiency. These are all of these water heaters, unfortunately, don't get a rebate from ComEd. However, there are rebates for an all-electric home. So if you have any questions about that, you can follow up with ComEd on that. The third option is solar hot water heaters, between $1,800 and $5,500 installed, but can be up to $13,000. This I like to think of as sort of a reach goal, a very progressive and green appliance or piece of equipment, because it's very expensive and can be sometimes not as synergistic as, say, solar PV, where you know, during a sunny day when you need cooling, you're going to have a lot of electricity provided to you. When you need hot water the most, the solar panels are going to be not providing as much as they would on a hot day when you may not need as much hot water. So plumbing and then freezing of pipes in this latitude is also problematic as well. So, but however, for a net zero home, this is a great option, and it can be combined with a tankless hot water heater to give you the boost if it's not providing all of the hot water temperature that you absolutely need. And for the sake of time, I will pass it back to you, Katie. Thanks very much.
Thank you so much, Albert. Thanks so much for sharing all these great resources with us. We're going to follow up after the session again and share those slides with you and the links and the tips for everyone as well. And we finally made it to the Q&A, the part that you've been waiting for, and asking all your questions in the chat. So I just wanted to thank you all again for presenting, and we'll get to some Q&A with Brett Bridgeland from ComEd, and he's going to facilitate some of the chat that's come through.
Yeah, we've got about 15 minutes here for Q&A, and we've gotten lots of great questions. It's been a pleasure working with all 4 of these builders this year with the launch of the new Electric Homes program. First, we'll go up. There are a few questions for Dick on ADUs specifically. Dick, I saw you responded a little bit. Quickly, what's the buzz on ADUs becoming available in additional locations outside of Evanston and maybe Chicago?
Yeah, great question. Yeah, so Chicago is a big deal. That ordinance was introduced to City Council. That will be rolled out in the next weeks. Currently, Oak Park is legal, and also Evanston. We've heard other municipalities looking at this. And in the chat, you'll see 3 links to AARP and other resources, the Urban Land Institute. So those are good resources to share with your housing and zoning folks in your municipalities.
Thanks, Dick. I'm going to throw one to Scott next, Scott Sanders. We talked, so some of the builders here talked about the envelopes. Can you talk about air sealing and how that factored into your homes in particular, and what some of the specific details are that you were keeping an eye on?
Sure. Some of the air sealing that we did among the 3 units, we basically did a good, better, best, something like that in terms of air sealing efforts. We did the first home in Tyvek. We did the second home in the zip wall system, the exterior panel, and then we actually did the third home in zip wall as well, with some additional interior air sealing details around the perimeter of the slab, window penetrations, some advanced air sealing up in the attic for penetrations coming through the top plates. And then I think Brandon is famous for having a penetration map for his plans all around the exterior of his home and how he's going to air seal. And we actually followed that as well to make sure we were making as few penetrations as possible, and that extreme attention to detail was paid to sealing those outside and inside before we sealed them up and insulated those walls.
Thanks, Scott. I'll give the next question here to Brian. There's a question about costs, and it's always the ultimate question, right? So Brian, I'll start with you. Have you done any cost comparisons of this style of construction compared to traditional build? Easy question, right?
Easy question, right. It's a continuous process is the real answer. It's difficult with panelized home, or the Zoetic Edison Park home specifically, because it's not apples to apples. We're using panels below grade, so where the foundation work starts and stops is different on a traditionally built home. And so it's kind of getting into the weeds on all of those things, not bringing natural gas infrastructure to the home, great savings, but more electrical infrastructure. So how does that play out, right? And so there's just a lot to dig into with multiple builders, multiple trades. So yeah, ongoing process, and maybe a better question next year when we have all the data.
Great. Did you have to upgrade your electrical service?
Yes, it's a 400 amp service with 2 interior panels instead of the traditional 200.
Okay. Brandon, maybe I'll jump to you. Anything you would want to add about the cost of your homes and things you might have done to control costs?
Yeah, for this home and in Wildwood in particular, focusing on offsite construction, so either highly prefabricated or full volumetric modular is what we're focusing on this development. So melding that kind of building typology with passive house, solar and battery, and bringing that all together. And in doing that, this was the most cost-effective passive house we have built to date, which was really cool. So, we're starting probably in like the $225 a square foot range for a home package in Wildwood.
All right. Let's see, Scott, I'm gonna go back to you. How did you choose the heating and cooling system that you ultimately used in electric homes? Oh, and by the way, there are a couple questions popped up. Can you clarify where you used gas and where you didn't first?
Sure. 3 units on this project in Forest Park. The first unit closest to the street that you could see in the video was the natural gas control unit, essentially. So that one we wanted natural gas to be able to compare energy intensity, energy use, and then overall energy comfort, I guess, as well, compared to the 2 all-electric homes that followed. So we have 1 natural gas home here and then 2 electric homes. The 2 electric homes are heated. One of them is with a completely ducted air source heat pump from Mitsubishi. So it's similar to what Mike was talking about at the beginning and what Brian was talking about, where it looks like a conventional air handler sitting down in your basement. You would have no idea that it's an all-electric unit. because there's nothing mounted on the walls, there's nothing mounted on the baseboards or anything like that. And how we came to choose that system was honestly Mitsubishi was the only manufacturer who offered a system that met the specs for our climate, and it was willing to put forward the effort to help us install it and figure out who to do it. So Mitsubishi is certainly pushing the envelope on that, which is why I'm glad that they're a sponsor of the tour, and Mike's been a great partner to help work through design details. And honestly, for Brian as well, he was involved in our project to help figure out what equipment to put in and how to do it as well.
Thank you. All right, I'm gonna ask a question. I'm gonna go in order to all four builders, and maybe starting with Dick. And the question is, if you're a home buyer, or if you're a builder who happens to be listening on this webinar, why go all electric for a new home? I'll start with Dick.
Great question. I think what comes with an all electric home is, I think, thoughtfulness. I think you've seen from all these examples, you don't just end up with an all electric home. You think about the envelope, you think about penetration, you think about thermal barriers that you just don't get otherwise. So I think you get quality, and with the ventilation, you also not just get energy efficiency, but you also get indoor air quality, higher IAQ, and also just healthier living. So I think that's the reason, is you really get the whole package.
Great. Brian, what do you think?
I think electrifying the home is the first step, and it just gives you so many more options to consider. If you've got a home with gas appliances, again, you're going to top out 98, 99% efficient, just as a physics limitation. And with the electrical, you have, sky's the limit as these technologies develop, and we electrify more and more of our homes and buildings. And also, even if it's not sustainably driven or carbon driven, for us, eliminating that gas bill, not bringing natural gas to the home, just the customer charge from people's gas is $35 and change per month for a single family home. So there, regardless of all the energy efficiency measures and things that we've done on the home, we've eliminated $400 of utility bills for that homeowner before any of that. So it's just a holistic way to look at it. Let's pay one provider to give us our energy, and then produce as much of it as possible, much as the regulations will allow. Right? You can't overproduce, but you can produce everything you can use.
Thanks. Brandon, what's your take? Why go electric? Go, Brandon, you're on mute.
I was doing that out of respect, All right, yeah, so really, you can't go to net zero energy if you have natural gas. There's no ands, ifs, or buts about that. So that's the first thing. If you're going to future-proof your home for the future, going all electric, things are becoming electrified. You look at the charts of dollars per watt of solar production or solar panels over the past 15 years. It's come down exponentially, and sometimes year over year exponentially even. And then you look at battery storage is probably going to follow a similar trend, maybe not quite a steep drop, but still, when you're able to produce energy, store energy, and from that produce and store energy, power your entire home, like what's there to really think about at that point for something? If you're thinking about a home as something that's going to last 100 years plus, and really that's the way we need to think of homes, as not a 10 or 15 or 30-year mortgage kind of investment, but this is a long-term asset that people are going to hold, so it should give you the returns you're looking for. Beyond that, I'm going to say health and safety, like bring a combustible fuel into your home. It doesn't happen every day, but there are homes that do have major gas leaks and explosions due to that. And why even have that as a risk factor if you don't need to, and you don't need to. And then just the health, you don't have carbon monoxide, you don't have a lot of the other off-gassing elements of natural gas and using that as a fuel source in the home. So, just creates a healthier, safer environment as well.
Thanks. And Scott, you've got 3 homes where you're testing out some different scenarios. Why did you try electric?
Yeah, I guess I'm maybe a bit more pragmatic or numbers driven, or worried more or less for adoption by the general public of solar versus gas, or all electric versus gas. And so believe me when I say that we are very much interested in going all electric, certainly at least for the combustion benefits inside. I mean, cooking on a gas stove is like having a campfire in the middle of your kitchen. And there's all kinds of bad stuff that comes out of that. So we just want to be able to have data to point to when we're in a conversation with a client, not just, hey, we think it's better, hey, we know it's better, and here's why. We have exact comparisons from one unit to another, and here's the information, here's the data, and then here's the long-term environmental impact, which is sort of a side benefit or an additional benefit on top of it.
Great. And I'm going to keep going with you, Scott, because there's some questions coming through about renovations to existing homes, and I know you do work in existing homes. If you're a homeowner thinking about a renovation and considering all electric, what questions might you ask, and what might next steps be?
Sure. I saw a question about a 2 or 3 flat, and also someone asking about putting in a Mitsubishi system for replacing a furnace. And that is certainly possible to do. I think Brian or Mike from Mitsubishi could answer that better to make sure that the system can hold the BTU or heating requirements and cooling requirements of the home. But overall, if you're gutting a house or gutting a 2 flat or 3 flat down to the bare stubs, there's absolutely no reason you can't go with all electric, just like a brand new construction high performance home. Certainly becomes a dollar calculation if dollars are driving the decision. But if there are other things behind it, the environmental benefits, the indoor air quality benefits, the livability benefits, then those just need to be factored in with different weightings, I suppose.
Great. Brian, anything you would add to that as well? I think you were chiming in on the retrofit conversation, if I'm reading correctly.
Yeah, I think, with rehab projects, you've got challenges, constraints, but you also have opportunities and things you can take advantage of. Thermal mass being one of them. Clients like to take advantage of those 12 inches of 3-width masonry that we've seen for 100 years in Chicago. So Chicago's a really interesting place to do these rehab projects. We have a great inventory of buildings here that a lot of other cities don't have. And so that equals opportunity.
Great. All right, we're going to do another round robin here, and with 2 minutes left, I'm going to give everybody a chance. What's your favorite thing, either technology or design element or what have you, in the home that you shared today? Let's go with Dick first.
That's a great one. I would have to say the air source heat pump. People are just blown away by saying 300, 400% efficiency, being able to take energy to move energy from the outdoors into the home in the dead of winter. So that's my favorite.
Cool. Brandon.
I'd say for me, it's more of a philosophy. It's, building a passive house, producing your own energy, and then being able to store that energy and converging those things together. It's really the convergence of that was the most exciting about this project for me.
Nice. Brian?
I'll follow Brandon up with a similar philosophy. It's the house as a system, right? Each decision informs the next, if A, then B. And all those things interacting together. Technology-wise, I've been looking for an ERV that doesn't always exchange the heat and humidity through the airstream. So having a bypass or having the ability to take advantage of free cooling or lower enthalpy in the outdoor air compared to the indoor air. That's kind of been one thing I've been looking forward to seeing in person, experiencing.
Nice. Scott, what are you most excited about?
I would say the continued evolution of the homes that we build and the homes that we're trying to help the community in Chicago at large build. I think everybody on this call, at least on the panelist side, knows that we're more than happy to share information and data and research so everybody doesn't have to make the same mistakes or try out the same things. And so that is an exciting part for me, that we can continue that research and development to be able to share that out to the high efficiency, high performance community.
Great. All right, we are right at time. Katie, we've got a lot of participants. What should they do if they want to contact some of these people or get more information?
Great question, Brett. Thank you for asking me. All of the participants, we're going to share their information in the follow-up email, so you can reach out. We also are copying all of the questions from the chat, So if there's anything that we missed or something that's more specific, we'll get back to you about those questions as well, and make sure everyone else is able to see some of those answers. We're also going to share the recording. So if you missed anything or you wanted to go back and watch your favorite part of All Electric Homes, you can, and share it with all your friends. I saw over 200 people on today at different points in time. So it was just really exciting to share all of this with you. And so I wanted to thank you guys again for attending, thank all of our speakers, thank our sponsors, especially ComEd Energy Efficiency Program and Mitsubishi Electric for sponsoring today's event, and for just sharing your expertise with us. This is always a really fun program, and we're really excited to continue the series. We hope that you guys learn something you can take back to your own home and try today or next month, or start researching for a future project. So I did hear a lot of questions in the chat about renovations and retrofits. So you're in luck. Next week on Wednesday at 3:30 is Deep Energy Retrofits. And we'll be talking about 3 different homes built at different eras, one in 1903, one in 1961, one in the 50s, a split level, a ranch, and a 2-flat. So all different styles of home that are all achieving almost net zero energy status. And so it's really exciting to see that you can even do that on a renovated home. So I saw that 150 of you signed up for the whole series. So we'll see a lot of you again next week. If you didn't, we'll also send you the link to next week's program afterwards if you want to check out next week and learn more about those retrofits. Then on July 22nd, we're going to do a passive house showcase, talk about even more passive homes. And on July 29th, we're going to talk about wellness and high performance and how to be balancing those 2 things together. So we're really excited about this series. We hope you'll join us all of the next Wednesdays of your July to hang out with us for the virtual Green Home Tour. And again, we'll send a follow-up email with all the links and the recording. So thank you all again. Have a great evening, and we'll see you all next week.